Okay, for this problem, we're gonna use the kinetic energy formula and also one of the gravitation formula. So the problem is asking how much work must the spacecraft engines perform to move the spacecraft to a circular orbit that is 4,980 kilometers above the surface. So we're gonna put this gravitation formula in this one right here. So we're gonna have 1/2 m g m over r squared. We can simplify that. That's gonna be 1/2 g m m r, and this is gonna be negative because it's an attractive force. This is the formula we're gonna use. Okay, for the first part, I wrote down all the information we have, and this is the mass of the spacecraft, this is the circular orbit, and this is the mass, and this is the spacecraft to a circular orbit, and this is the surface we need to go around. So first, and also we need the mass and radius. So first we're gonna need to find the r's for these r's for this problem, and that's gonna be r1 equals 2,440 kilometers, which we need to change to meters, so times 10 to the 3 meters over 1 kilometer. And all these we're gonna to add it to the r. That's gonna be the mass r. So that's gonna be 3.36 times 10 to the 6. And that's gonna give us 5.8 times 10 to the 6 meters. Then we need to find the R final, and we're gonna use, okay, for this one we use this one, and for this one we're gonna use the kilometers. So 400 and 4,980 times 10 to the 3 kilometers over meters over 1 meter plus the R of Mars, 10 to the 6, and that's gonna give us 8.34 times 10 to the 6 meters. So now that we have those two, we're gonna use that formula to get the initial and the final energy. So the initial energy is gonna be negative 1/2 times the constant of G times the mass of Mars times the mass of the spacecraft over our initial R times 10 to the 6. And that's gonna give us negative 1 8.179 times 10 to the 10 joules. For the next part, we're gonna find the second energy, and that's gonna be negative 1/2, and it's gonna be all the same, 6.67 times 10 to the negative 11 times 6.39 times 10 to the 23 kilograms times the mass again of the spacecraft all over the second R, which is 8.34 times 10 to the 6, and that's gonna give us negative 8.2 times 10 to the 9. Now we're gonna use the sum of all the forces, the sum of the work and the energy. So that's gonna be E final minus E initial, and that's negative 8.2 times 10 to the 9 joules minus 1.18 times 10 to the 10 joules, and that's gonna be our answer, 3.57 times 10 to the 10 joules. And that's it.